Hi everyone, just continuing on with the geometry of simultaneous linear equations. So I'm going to start this one off by just saying that there was something I left out of the last video, and that was something I even mentioned, I just forgot about it. But I wanted to show with question B in this part right here, that if we actually graph these two equations, so graph the first one, just highlight it, drag it down to the axes, there is the line, okay? If I take the second equation and drag it down as well, you can see what happened just there was the red just went straight over the top of the blue, so we can see that they are the exact same line. Okay, just wanted to point that out. Anyway, going to get stuck into this question down here now. So find the values of m for which the simultaneous equations mx plus 3y equals 1 and x plus m plus 2y equals m have infinite solutions, no solutions, and a unique solution. I'm going to go through this in two different ways. So first I'm going to show you the algebraic way that we've kind of looked at in detail here so far. And then I'll show you another method using matrices, which I would usually prefer. I just find it to be a little bit nicer. So the thing is, we're considering two situations here. We're considering the infinite solutions and no solutions. And what we learned about in the last video was that this occurs, both of these occur, when we have the same gradient, okay? And just whether they are infinite solutions or no solutions depends on the other ratio between the coefficient of y and the number on the right-hand side of the equation. So the thing is, I'm going to just set this up so that I have the ratio between the coefficients of x and the coefficients of y. And I'm going to put them equal to each other because when they are equal, they're going to have infinite or no solutions. So to begin with, I'm going to say, what was it, m to 3 must be equal to 1 to m plus 2. So I've put the two ratios equal to each other. Just in case you're wondering, the 1 is coming from right here, the number in front of x. Okay. Now remember that ratio sign means divide. So this is really m over 3 equals 1 over m plus 2. And so this is just an equation that we can solve now. I'm going to use a bit of cross multiplication. So m times m plus 2 equals, well, 1 times 3, which is just 3. Expanding this out, m squared plus 2m, and I'm going to take away the 3 on both sides to make it equal 0, which means I can now use the null factor law to solve this. So factorizing this, hopefully it's fairly easy to see that your factors are going to be m plus 3 and m minus 1, two numbers that multiply to give negative 3 and add to give positive 2, and that should still be equal to 0. This means that m is equal to negative 3 or m is equal to 1. Now one of these situations is going to give infinite solutions and the other is going to give no solutions. So I think the easiest thing to do from here is simply to test, okay? So we're going to test it in the equations. Okay, so the first equation, mx plus 3y equals 1, I'll go when m equals negative 3. So negative 3x plus 3y equals 1. That would be the first equation. And the second equation, x plus m plus 2y. So that's going to be x plus negative 3 plus 2, which is negative 1y, so that will actually be a minus there. Equals, and that was equal to m, which in this case is negative 3. So these two equations here, we need to have a look at them, and I think that it's fairly easy to see that we could turn one into the other. If I were to divide the first equation here by negative 3, it would become x minus y equals negative 1/3. And that's not the same as x minus y equals negative 3. So this is a case of no solution. They have the same ratio between the coefficients of x and y, but the y-intercept is going to be different in each case. So then I'll test when m equals 1. And we can pretty safely assume that this is going to be the infinite solutions case, but we'll just show that is the situation anyway. So the first equation will be x plus 3y equals 1. And the second equation will be x plus, now 1 plus 2 is 3y, and then m, which is just 1. Well, we can see immediately that those are exactly the same equation, and so this is a case of infinite solutions. The last situation is to find when there is a unique solution. Well, the thing is, we know that the infinite and no solutions happen when m is equal to 1 or negative 3. So what this actually means is that the unique solution happens in every other or happens for every other value of m. So I could say when m is an element of the real number set excluding negative 3 and 1. And yeah, that's all we really need to do for that part. So getting the getting the m values for a unique solution is actually really easy once we have done the other work. Right, the alternate method. So that's how we can go through that entire problem, okay, and get to the solution that way. Now, alternatively, I'm going to use matrices to do this. So when you did matrices in the past, you learned about finding the determinant. And the determinant of a matrix is really nice for determining whether solutions exist in simultaneous linear equations. So what we do is we use the fact that the determinant of a matrix is equal to 0 for infinite solutions or no solutions. And you might remember that the determinant of a matrix is equal to AD minus BC when the matrix is of the form ABCD, like that. So the thing is, I'm going to set up the matrix for these equations. So I'm going to say let A equal the matrix which has m, 3, 1, and m plus 2. That's an m, 3, 1, and m plus 2. This means that the determinant of A is m times m plus 2 minus 3 times 1. And we let det A equals 0 because that's going to tell us when we have infinite or no solutions. So 0 equals, and I'm going to expand that out, m squared plus 2m take 3. And you can see that right now we are at this step right here. Okay? So we've just done it in I would say, a much less algebraic sort of way. And from this point, you're working out is exactly the same. You just need to factorize using null factor law, and then solve it, and then test the values of m in the equations. So it's really up to you to choose which way you want to go about it. As I have a personal preference for using the matrices. I just think it's quite nice and a bit of an elegant sort of way to work it out, but that's just me. And yeah, you're obviously going to have your preference as well, so leave that decision up to you. Anyway, that's all there is for this, so I will see you all next time.